Hey, what's up? Welcome back. You're watching day 13 of the Advent of Code. This is called transparent origami. The idea is that we have some sort of transparent paper that has dots on it, and we're gonna fold it and keep folding it, and then ultimately you should be able to see the dots at the new locations after it's all folded up. So the input that you receive is all of the dots, and then also some instructions for how to fold. And this is kind of what you can think about in terms of where the dots are. So these pound signs, octothorpe, whatever, are where the dots are on the grid. And then the periods are just the empty spaces on the grid. And so what we're gonna do is try to take in the list of all the dots, put them on a grid, and then we're gonna look at those fold instructions and fold the paper. So what we need to do is have a 2x2 array. And then when we're given a fold instruction along some line, we wanna take all of these dots and move them up to their related spot up above. So this bottom corner ends up being in the top corner, the almost bottom corner becomes almost the top corner, etc., etc. And so you'll fold several different times and ultimately end up with something like this. So for part one, we want to just look at one fold instruction and then see what's on our transparent paper. So that's what we're going to do. So let's start off here by adding day 13, and we're going to add paper.rb and class paper, and then we'll add our spec, day 13 spec.rb, and we're going to say require relative day 13 paper.rb, and we're going to describe paper, and we're going to say that it correctly parses the points and the fold instructions. And we're just going to give it some raw input. So we'll say that input here looks like this. This is called a heredoc. It looks like this, like a heredoc, I think. It's basically a way to make an inline or a multi-line string in Ruby. It's also a convenient way to drop in a bunch of instructions. So in our case, we don't need all of these instructions, we just need some of them. And so what I'm going to do is grab some of the points that are pretty close to 0 so that we can have our test grid be pretty small. So this should give us some decent number of results. So now we'll say paper is equal to paper.parse input, and then we'll pass that in. And then we're going to expect that paper.grid to equal something like this, where we're going to have, we need to figure out what the max number is here. So it looks like 4 is the max number of rows and columns. So we actually need 5 rows and 5 columns. So then we're going to have, I think, a bunch of zeros at least to start. And then at 0, 3, we're going to have a 1. And then at 4, 1, we will have a 1. And at 3, 4, 2, 3, 4, that's going to be a 1. And then at 3, 0, we're going to have a 1. And then we're also going to expect that paper.fold instructions to equal, and I guess let's just try to have the fold instruction be the string and then the value. So we'll just expect that it's an array of y7 or something like that. And then x5. So that's what we're going to kind of try to end up with when we parse. So let's go try to parse this out. So we're going to say self.parse input. And we want to return a new paper, paper.new, and that's going to have the grid and the fold instructions. Okay. And it's failing, no method, undefined method input for the spec. Oh, this is, okay. You have to use the equal sign. Okay, so, yep. let's see. Okay, undefined local variable or method grid. So there is no grid here, right? So we have to figure out the grid based on the input. So the first thing we want to do is say input is going to, we want to split it on, I think we want to split it on like 2 new lines or something. In the instructions here, there's like a new line after this row and then another new line here. And so what I think that's going to work. And then we'll have like dots and instructions, at least like the raw versions of those. So let's p dots and we'll p instructions. We'll just put like a line between them and then see what we get. Okay, yeah, so that looks right. So we've got our dots and then we've got our fold instructions. Now we need to properly parse the dots. So dots.split on new line, that should give us back each kind of like comma separated pair. And then we want to map that onto a dot, dot split on comma, dot map to I, and I think that should give us like nice dots. Okay, so we'll just say dots is this, or grid, no, dots, yes, dots. And then for our fold instructions, we want to say like instructions is equal to instructions dot split on new line dot map. And then for this one, what we want to do is just remove fold along space. So we're going to say g sub like fold along space. We want to replace that with nothing. And then we want to split on equals. And then we want to, I guess we technically want the last element to be an integer. So yeah, then we can like map all of that onto, like, it's going to be like a string and then a number. So x and n or something. And then we want to say x n dot to I. Oof, that's a long one. Okay. So this is like one of the beauties of Ruby is you can just really chain on a lot of different stuff here. But hopefully this is not too hard to read. And I actually think this is too hard to read. And so I'm going to make this a little clearer by saying line and then line.gsub that thing and then split on equals. Technically, what we could do is have it map, and then have like each instruction on a different line. And that sometimes can make it a little clearer. But for now, this is fine, whatever. Okay, so now we've got, good. All right, so we've got y7 and x5. That looks right. And then we want to pass in this, we'll just call it instructions now. And we don't need to print anything anymore. We're still going to have an error because we don't have an initialize method. And grid, oh, right. So grid is going to be like dots dot, we need to find the maximum first dot and the maximum second dot, right? So dots dot map first dot max, and this is going to be like max x, and then max y will be last. And then what we want to do is create a new grid that is an array of max x, and inside of that array we want another array, and that is going to be max y. And we're going to just fill the entire thing with zeros for now. And then what we can do is say dots dot each do dot. Actually, we can destructure in the block argument here with x and y. And then we can say grid at x and y is equal to the 1, right? Okay. Now if we run it, we have a grid variable, but undefined method square bracket equals for nil class. Okay, so, oh, right, this should be +1, I think. I think that's right. No? Oh yeah, this is right. Now, this is the next error that we have. The initialize method doesn't actually take grid or instructions yet, so we have to say def new, or no, def initialize, and we're gonna have grid and instructions. At grid is equal to grid, and at instructions is equal to instructions. And we'll just make a reader for grid and for instructions. And then we want to change this to be instructions instead of fold instructions. And we'll run our test. Hey, we've got a passing test. Nice. We can remove our put statement. So hopefully this makes sense. Basically, it's just taking the input and doing a bunch of stuff to get what we need out of that thing and into our class. Okay, so now that we have our grid, we kind of need to figure out like how this thing actually works. So one thing we want to do is print it out. So let's add a method here, 2s, that will print this thing out. So we can add another test for this too. It like prints as expected. We can use another heredoc here for testing this part out. So this can be kind of handy. So let's actually just use our same input in the paper and all that. In fact, let's use a let block again. Let paper be do and this whole thing. There's a couple other RSpec features too that I'm excited to share in future episodes. All right, so we've got our, this should still pass. Let's just make sure it does. Okay, cool. And then we don't need all of this. And what we can do is we can say we expect that paper.2s to equal. And here we can use another heredoc. The all caps thing that you use at the start and end can actually be whatever you want. And in some editors, if you put like SQL, then it'll like syntax highlight for you. So that can be super handy. Here, I'm just putting whatever in for input. But what I wanted to show was that like when you're using a heredoc as an argument to a method, it gets super freaky because like the close paren for the method call is like at the end of this line, but like the content for the string goes below. So yeah, it can get kind of funky. So I guess like we're basically rebuilding this grid, but we're going to build it with 3 dots and then a pound and then a dot and then 5 dots and then 5 dots and then pound sign dot 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 pound sign and then pound sign dot pound sign pounds or no dot pound sign dot dot dot. Okay, so let's see what we get. We got nothing because it's not implemented yet. So what we want to do is we want to say at grid.each do row row.each do cell. And here we want to actually let's map it map and we want to say we want a pound sign if the cell is 1 and we want a period otherwise. So if the cell is equal to 1, then put a pound sign, otherwise put a dot. And then I guess we can join this with new lines. I don't know, let's see. All right, so we got very close. This one is just missing an extra new line. So what we can do is, I'm gonna just cheat and say plus new line at the end, because that's whatever. It's fine. Okay. All right, so that totally works. So now we have a method to print it out and we have a method to generate it. Now let's figure out how we're actually going to fold. So we have to use those fold instructions, X7 and Y5, to know sort of like which line we're folding on. Are we folding left? Are we folding up? So basically the way this works is we are always either going to fold everything left or we're going to fold everything from the bottom up. And I think what makes the most sense is to first just move all the dots up to the upper part of the array, the upper part of the grid, and then instead of like having to figure out how to like make a new array and move it over and everything, what we can do is create a new array by selecting only the rows that are above a certain mark, or selecting only the columns that are above a certain mark. That way we can kind of just like cut the grid in half by using filter or select. So it, I don't know, let's say like it folds up as expected. So let's say we're going to take our same paper and we're going to say like paper.fold up, and we're going to expect that paper.grid to equal something. And I guess we also, like in our instructions here, in the fold instructions, they give us like which axis we're going to fold along. So here when we see y equals 7, we're going to fold along the 7th like row or the 7th column. I can't remember which, but let's say, okay, so here in this case, let's fold up on row 2. So this is row 2 right here. So if we were to fold up row 2, then we should just end up with these 2 rows. And let's see, so I'm actually just going to copy all of the rows and paste them in here so we have reference. So I'm going to move this 1 up here, so that's a 1, and then I'm going to move this 1 all the way to the top, and then I'm going to move this 1 up here, and we're just kind of like making it symmetrical. And then we're going to remove those bottom rows. Undefined method fold up. Yep, we haven't made it yet. Def fold up some number. And here is where the magic actually happens. I think we can make this a little clearer. Let's call it crease, I think. And then the idea is that we want to iterate over the entire grid. So at grid.each with index, do row and I, and then row.each with index, do cell and j. And we want to say something like, if the cell is equal to 1, then we want to like copy it up. But I guess we want to skip over any rows that are smaller than that are like above the crease, right? And so we want to say like next if I is less than crease. Okay, and then if the cell is 1, then what is the position on the top, right? So like here we moved this one at, what is this? 0, 1, 2, 3. We moved it from 3 to 1. So from 3 to 1. So we need to move things from 3 to 1 when folding at 2. And we also need to move things from 5 to 0, from 5 to 0 when folding at 2. Okay, so this is where like sometimes it can be helpful to just write out a couple of those use cases so that you can sort of get the math right. And so in order to get, like we have crease is the number 2, so we have the number 2. And then I try to think about like what is 3 relative to 1 and what is 5 relative to 0. And then we also have these inputs I and j. So when we get to 3, 0, so when we get to 3, 0, I will equal 3 and j is going to equal 0. And what we want, and I guess like crease is going to equal 2. And what we want is we want to set 1, 0 equal to 1. Okay, and so how do we get 1? How do we get this 1 value? And I think it's something like, it's going to be something like crease minus I minus crease or something. Okay, so this is 2 minus 3 minus 2, so that's 1. So 2 is the crease value. So that's 2. So we get 2 minus, and then I again is 3. So 3 minus 2. So we get 2 minus 2 is, okay. So then let's just double check to make sure this works for the other case. So we're moving from 5 to 0. So this should be 0. And so the crease in that case is 2. I in that case is 4. and then minus 2. So 4 minus 2 is 2, 2 minus 2 is 0. Okay, I think this works. So then we want to set like at grid at crease minus I minus crease to, and then like J. J is actually not going to change in this case, right? When we're folding up, the column doesn't change. So J stays the same. We'll set that equal to 1. And I think that's actually all we need to do. Okay, so then what we need to do is like, or I guess like that should bring us or like get us pretty close to this, I think. Let's take a look. All right, so yeah, okay, so the first 2 rows are good. Now the next step is to just like filter out the rest of those rows. So now we need to say something like at grid dot select with index. This is kind of cool. So like both map and select don't have like an each with index like array does, but you can add on dot with index, and that will make it so that it sort of like wraps or decorates the block so that you get an index with it. So we'll get row and I here, and then we want to return rows if, yeah, so like if I is less than crease, or maybe we just say I less than crease. Let's see. No. Oh, I guess we also want to like update grid at grid equals. Hey, it worked. Cool. All right, so now we need to fold left. So let's fold left. And it's going to be basically the same thing, but just a little different. So fold left is, this time we're going to work with J. So I is going to stay the same. And we're going to change J. Actually, before we do that, let's write a test. And here it's going to say folds left as expected. And we're going to say fold left at 2. We'll copy our stuff here. Okay, so when we fold left, this 1 is going to come over here. And this one, oh, this one is it's already got a spot. And that's okay. The numbers can overlap. We don't need to increase it. We just need to like make sure there is a dot there. So we'll set it and it won't matter. And then we're going to delete the rest of this array and we should end up with this. So there is no fold left method. So let's implement it. And this part is not going to be the same. Okay, so if this, yeah, so now we want to skip the rows that are less than the crease, or I'm sorry, we want to skip the cells that are less than the crease. And then if there is a cell, then we want, maybe it's the same. Is it the same? Crease minus J minus crease. I don't know. That can't be it. That might be it. Maybe. I don't know. Let's see. So then what we want to do is we want to filter out the, yeah, so now we need to say like row grid.select or grid.map. Yeah, grid.map and then row.select with index do cell and J. And here we want to just return J is less than crease, I think. Holy moly. Okay, awesome. That's exciting. Okay, so let's see. All right, there's a fold instruction, blah, blah, blah. So why don't we try, yeah, let's take this input. Oh, you know what? We haven't actually figured out how to make a fold instruction do its thing. So let's make a method on here called step. And step is going to take instructions.pop. So we'll just pop off an instruction. And we're going to get back the like direction and the crease or something. And then we want to say like if dir is equal to y, then fold up crease. Else fold left crease. And okay, so then we've got to do our file thing. So file.read lines, or actually just file.read argv.input or .first. And we're going to depend on paper to parse this all. So paper is paper.parse. And then what we want to do is say paper.step. And then we want to say, what does it actually want here? So after the first fold in the example above, 17 dots are visible. So we also, I guess, need to count how many dots there are. Dots. And this can just be at grid.flatten.count the ones. Puts paper.dots. Not dogs, dots. Okay, so then what we want to do is add example input. And we're going to grab all of this. And we're going to paste it in here. And we're also going to want input. And that is going to be our puzzle input, which is here. And then we can run this Ruby day 13. All right, 10 dots. 10 dots, that's wrong. There should have been 17 dots. So what happened? So puts paper. Maybe we folded the wrong way. 17, okay. So we must have folded the wrong way. And then if we fold again, paper.step, do we get, oh, there's our 0, cool. All right, it's like on its side, but whatever. Relative to this, I think that's okay. So part 2, finish folding the transparent paper. According to the instructions, the manual says the code is always 8 capital letters. So what we need, oh, right, also we've got to go with our input. And we got back 11? No, we need to do all the fold instructions. So how does that work? I guess like run or something, and we'll just say like while instructions.empty, while the instructions are not empty, step. And then down here we can just say paper.run and 0. Let's see. Puts self 0. How are there no? All right, so what's super odd is that there's only 6 dots here, but it's super tall. And so I feel like we're folding at the wrong spot for some reason. So let's take a look at our logic here and see if we can figure out what's going on. Okay, so the very first instruction in our input is fold along 665. So when we call step, this is pulling off the instruction and then folding it somewhere and then giving us, let's just print out crease and see what that gives us. Okay, that didn't work as expected. Puts paper.step. We don't actually need to print that. Okay. 6. Crease is 6. Huh? Oh, that's the last instruction. Okay, hold on a sec. Instructions.pop. Oh, that's going to pull off the last one. We want shift. Shift. And now we want to put paper.dots. Boom, 669. And if we did it with the example, example input, we get 17. Okay, all right, so 17 was the example, 669 was ours. Awesome. So part 2, finish folding the transparent paper according to the instructions. The manual says the code is always 8 capital letters. So, this one is a little interesting. It's basically just like print out the ultimate grid, and then hopefully you can read it. So let's try to do that here. And then instead of step, I guess we want to like run it, run, and then print out. Okay, so that is the example input. And then for our input, we get this, CM, F something. Okay, so like UEF. So yeah, UE. Okay, so it's backwards. F Z C U C J. Okay, it's backwards in like all wonky. Let's see if we can transpose. Boom. Here we go. U, E, F, Z, C, U, C, J. Awesome. And that is the answer for the puzzle right here. And that's just the answer for my input. Thanks so much for watching. This has been day 13 of the Advent of Code for 2021 in Ruby. Hope you enjoyed that. And yeah, I guess we'll see you next time.